Okay, get this. What if a problem that stumped the greatest mathematical minds for 2 whole centuries was just solved? We're talking about a potential discovery that could literally rewrite the rules of algebra as we know them. See, for 200 years, a certain type of equation was considered impossible to solve, until, maybe, now.
And that's the big question we're diving into. What actually happens when a boundary, one that has defined an entire field of science for generations, just shatters? The ripple effects of something like that could change, well, everything. So, to really get what's going on here, we first have to understand the problem itself. We're digging into something called high-degree polynomials. These are incredibly complex equations that have been a total headache for the world's best mathematicians for a very, very long time.
And look, we're not talking about your basic high school algebra here. The equation at the center of this story was a 20th degree polynomial. To give you an idea, the complexity of an equation like that is it's astronomical.
And here's the real kicker. It wasn't just considered difficult or too complicated. No, it was thought to be mathematically proven to be literally impossible to solve perfectly. For centuries, mathematicians just had to settle for close enough approximations, never the pure exact answer. So how on earth did this idea of impossibility become a cornerstone of algebra? Well, it all goes back to a declaration made nearly 200 years ago, one that basically built a giant impenetrable wall around what mathematicians believed was even possible to solve.
If you look at the history, it's pretty wild. Way back in the 16th century, geniuses like Cardano and Ferrari figured out how to solve third and fourth degree polynomials. And then, nothing. Progress just hit a brick wall. For almost 300 years, anything higher remained a total mystery. Then, in 1824, a mathematician named Niels Henrik Abel seemed to close the book on it for good, forcing everyone to just use approximations for the next 2 centuries.
And this is the wall itself, Abel's impossibility theorem. Basically, it states that you just can't create a single universal formula to solve equations of the 5th degree or higher using the standard tools, adding, subtracting, multiplying, dividing, and taking roots. For 200 years, this was treated like mathematical law.
But what if that law wasn't the final word? This is where Professor Mourad Sultan Ezouidi enters the picture. He's the mathematician who's boldly claiming to have found a way right over that 200-year-old wall, arguing that the limit was never as absolute as everyone thought.
And this gets us to the heart of this potential breakthrough. It's a completely new method that doesn't just try to find a loophole in Abel's theorem. No, it argues that the whole thing was based on an incomplete picture of how algebra actually works.
So, why did the old ways fail? Well, the classical toolset was kind of like trying to build a skyscraper with just a hammer and some nails. As the equations got more complex, the number of moving parts just exploded. We're talking millions of terms. It was completely unmanageable. So everyone was forced to settle for close enough, and eventually just accepted it as a fundamental limit of math. And Professor Ezouidi's entire perspective is captured right here. He's saying the problem was never unsolvable. Mathematicians were just using the wrong tools. The answer wasn't to keep sharpening the old hammer, but to invent a whole new toolbox.
The difference is just night and day when you put the two approaches side by side. Where the classical method said impossible, Ezouidi's theorem says here's the exact answer. It moves us away from approximation and toward 100% verifiable symbolic accuracy. And maybe most importantly, it replaces this acceptance of limits with a rejection of what he calls fatalism, this idea that some problems are just meant to be unsolvable.
All right, so how does this new method actually work? Now don't worry, we're not going to get lost in a sea of complex formulas, but we can understand the elegant idea behind how this is supposed to be possible.
Think of it like a 4-step dance. First, you deconstruct the big, messy polynomial into simpler pieces using a new framework. Then you apply this powerful universal recursive formula, one that Ezouidi claims works for any degree. This step-by-step process generates a chain of perfectly exact coefficients, no guesswork involved. And finally, that chain reveals the exact roots of the original equation. Boom! So here's the real genius of it. Instead of trying to force a solution onto the equation from the outside using approximations, this new method actually coaxes the polynomial to reveal its own solution from within its own unique structure. It's a total shift in how you even look at the problem.
Now, if this claim holds up under intense peer review, the implications are just staggering. We're not just talking about solving one tricky equation, we're talking about redefining the very boundaries of algebra. This could unlock brand new tools for fields like cryptography, engineering, and even theoretical physics.
So what we're really looking at is this massive shift in perspective, a journey away from approximation and toward exactness, away from a mindset of impossibility and toward one of discovery. It reframes Abel's historic theorem not as a final limitation, but as what Professor Ezouidi calls a revelation, a crucial milestone that has now, potentially, been surpassed.
And that really gets to the core of it. The goal here wasn't just to find an answer, it was to change our very understanding of what an answer can be. It's about shifting the whole definition of solving away from just getting close enough and back toward finding the pure algebraic truth.
So, the ultimate takeaway is this. An equation that for 200 years was held up as the symbol of what math couldn't do might now be the very thing that proves there are no absolute upper limits. That any polynomial, of any degree, holds the key to its own perfect solution, just waiting to be unlocked.
And that leaves us with a really fascinating thought to chew on. If a 200-year-old mathematical impossibility can potentially be overturned, what other scientific impossibilities out there aren't really laws of nature at all, but just the current boundaries of our imagination, waiting for someone with a new way of thinking to come along and break them down?